Are you recording? Recording? Great. Okay, so I have this beaker here that's sealed off, and I have this syringe that I can pull up on to make the pressure inside of this thing drop dramatically. Now, if you look closely at this thing, there's actually water in there, which is kind of a clever thing to do. And what I'm trying to do is water is incompressible, so I can compress and expand the air as much as I want. The water's not going to do anything. But what that does is that means that my change in volume, instead of changing the volume by 30% or something like that, by making the syringe go up, I can change the volume by like a factor of 2. And so, as I say in the lecture, if I do this fast enough, I should be able to make the temperature drop through adiabatic expansion. So all the other processes, like isothermal, those are constant temperature processes, or maybe the temperature is going up, some things like that. This is really the only process where the temperature drops. So let's see if this happens, and I'm going to go ahead and collect the data here. Let me see if I can put the cursor over the green thing. I can't see it. Alright, there we go. Alright, so I'm collecting my data. It's at atmospheric pressure, 100 kilopascals. And I'm going to go ahead and pull this down. And you're going to see the pressure just drop dramatically, and you want to look carefully at the temperature, see if the temperature drops too. Ready? I'm going to pull the syringe up. The temperature is going to drop. There it goes. Drops all the way down to something like 67 kilopascals, and you can see pretty clearly that the temperature dropped by maybe 0.2 of a centigrade, something like that. And now over time, the temperature is going to climb back up again, because this only works when it happens rapidly. So over time, despite the fact that the air is cooler inside of this thing, the outside of the container can exchange energy with the inside of the container through the walls of the thing, and it'll sort of climb back up to room temperature. And so, if I had done this very slowly, it would have just stayed room temperature. But because I did it rapidly, it actually drops. It drops and sort of comes back up again. And I can let go of this thing. I can let go of the syringe. So the syringe is kind of coming back down. And the pressure inside is going to go back up to room temperature. So you can see the pressure kind of going all the way back up there. Okay? So there you go. So I showed that the temperature really does drop. And the importance of this thing is that if I was going to do adiabatic compression and show that the temperature increases when I do this, when I compress it instead of expand it, one could imagine that, well, really the temperature increase was from, say, the friction on sort of the rubber tube here against the side, and you might accuse me that the temperature goes up because of that instead of because of this adiabatic process. But here, because I'm doing it in expansion, there's still that friction between the rubber and the side, and so you might expect the temperature actually to go up because I'm expanding it, but in fact it drops.